Welcome to Unit 3B. We are still studying triangles, but our section 1 today is on isosceles and equilateral triangles. So we've already talked about what those are, but we're going to dive in a little bit deeper into what properties they have. So first, let's look at isosceles triangles. So remember, isosceles triangles are just a triangle that have two congruent sides, and we're going to call those two congruent sides legs. Okay, so those are our legs. We know that AB is congruent to BC because it's an isosceles triangle. The angles where the legs intersect, so angle B, is our vertex angle. Okay, and then the other two angles are called our base angles because we're going to call this other side the base. So the base is the side that's not congruent to the legs. And then angles 2 and 3 will be the base angles. So just some vocab for you guys to know. Base angles, okay, there you go. So isosceles triangle theorem. If we have two sides of a triangle that are congruent, then the angles opposite those sides are congruent. So this means that anytime we have an isosceles triangle, we have two sides congruent, the angles opposite those sides are congruent. So our base angles are congruent all the time in an isosceles triangle. Okay, so then the converse of that, so remember the converse is just when we reverse the statement. If we have two angles of a triangle that are congruent, so like this picture, those two triangles angles are congruent, those are our base angles. Okay, then we know it will be an isosceles triangle. Okay, so then those sides opposite of those angles will be congruent. Okay, so again, if you see this picture, we know that these two sides are congruent. So let's do some examples. Okay, we want to find each angle measure. So in number 1, we know we have an isosceles triangle because we have two sides congruent. We have one base angle of 68 degrees. So we know by those theorems that the other base angle is congruent and it is 68 degrees. Now, that is the measure of angle J. Now, if we want to find that third angle, okay, we can just take our triangle angle sum. So all three angles add up to be 180. Subtract 68 two times from 180, and we get 44 degrees. All right, if number 2, we are given the vertex angle. So that is the angle that is different than the base angle. So these two would be our base angles because they're across from the congruent sides. So now if we want to find the two base angles, we're just going to take 180 degrees minus 106. We get left over of that 74 degrees. And then we're going to take 74 and we're going to divide it by 2 because our base angles are congruent. So you get 37 degrees for both of our base angles. All right, in number 3, it is showing that we have base angles congruent, so 77 and 77. So that means that we know that these two sides opposite those angles will be congruent. So we know the measure of side YZ will also be 12 centimeters. And now again, we want to find the measure of angle Y, which is our vertex angle. Okay, so we are just going to take our triangle angle sum of 180, subtract 77 twice, and we will get 26 degrees. All right, I want you to try number 4, okay, and then I want you to try number 6. And we will come back together on those in class. And we are going to skip through these, okay? And I want you to go to equilateral triangles. Okay? Equilateral triangles. So remember, equilateral triangles are a triangle that have 3 congruent sides, so all sides are congruent. Okay? So it says a triangle is equilateral if and only if it is equiangular. Okay? So that means that if we have the measure of angle A, B, and C all equal, so it's equiangular, then it has to be equilateral. So then we know that the measure of AB will equal the measure of BC, which will equal the measure of CA. Similarly, the other way, if we know that the sides are all equal, so the length of AB equals the length of BC, which equals the length of AC, then we know that the angles must also be congruent and their measures are equal. So if we have an equiangular triangle, we know it is equilateral. If we have an equilateral triangle, we know it's equiangular. So example 11 shows a triangle that has two 60-degree angles. Well, we should know that this is also 60, but if you forget, take 180 minus the two 60s, and you will get 60 degrees. Okay? So it is an equiangular triangle, which means we also then have an equilateral triangle. So we know that these two sides will both be 9 feet. Okay, so look at 12. 12 is an equilateral triangle, so every single side is going to be our 24 centimeters. So if it is equilateral, then we know it must be equiangular. And if it's equiangular, all of our angles are the same. So 180 divided by those three angles is 60 degrees. All right, I want you to try number 13, and we will look at those in class together. Have a good day.